All right, so it's Friday. Happy Friday, end of your first week. 9 more to go. And today we are going to look at subsetting. So subsetting is a important topic. It's something that R does very well. It's very powerful and can be used in all sorts of applications here. So we'll just start by, so a lot of this should have been covered in Stats 20. We're going to spend a good chunk. I mean, today's lecture might be a review for a lot of you, but we'll go over everything here. All right, so we're going to start off by subsetting atomic vectors. All right, and so here I've created this vector here, x, 2, 1, 4, 2, 3, 3, and 5.4, and the spots after the decimal kind of indicate where they were in the original vector. So this is, this is the first, second, 0.3 is for the third element, and 0.4 is for the fourth element, okay? And you can subset a vector using positive integers, negative integers, logical values, character vectors, and things like that, okay? I think this is, positive integers is probably the method that we are most familiar with and use very frequently, okay? So you can just say I want the third and first element, all right? And indeed it pulls out the third and the first element. Order is a function that when you apply it, it will tell you I guess the index that you would need to find in order to put things in order, okay? So if you want x to be in order, you would subset x based on this order 1, 3, 2, 4, and that would arrange it from least to greatest, okay? Order is very different from rank, okay? Rank tells you kind of which one's the smallest and which one's the largest, but it's going to be different, okay? If you subset using a duplicate index, so you can say give me the first element, and you can say this multiple times, 1, 1, it's going to return that element multiple times, okay? And it has no problems, no complaints there, okay? If you give it something that's not an integer, it's going to just silently kind of truncate these, no complaints, no warnings, and so 2.1 and 2.9 will get truncated down to 4.2, all right? I'm sorry, to the number 2, and it will return back the second element, which is 4.2. All right. If you give it negative integers, it will remove those elements. Okay. So if you say negative 3 and 1, it will take out the third element. It'll take out the first element and give you what's remaining, which will be the second and the fourth elements. Okay. But you can't mix both negative and positive values because that's confusing, right? So you're saying I don't want the first value, I do want the second value, but then what's it supposed to do with the third and the fourth values? Like, is it supposed to give it to you or not? It just says only zeros can be mixed with negative subscripts. Okay. All right, and then the other thing that's very common is using some kind of logical vector, right? So here's our original x vector, and you can say I want true, true, false, false, and it will return back the elements that correspond to true and not return the ones that are false, right? So here it returns the first and second elements because of true, true. Here it says x greater than 3, and so it's going to create a true, false vector. In this case, x greater than 3 is going to be false, and then true, 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 and so it returns everything that's greater than 3, okay? So here you've got the comparison inside the single square bracket to subset, right? And I think this is all familiar with you guys already. This is something you've probably had to do many times as well, right? If you have a logical vector, or really any vector that you want to, actually, no, that's not true. A logical vector here, it's going to recycle. So here I've got 4 elements, and here I've got 2 elements. So it recycles the true, false And this is equivalent to giving us true, false, which will return the first and the third elements. Okay. If there's a missing value in the vector that you give it, it will return a missing value. Okay. So if you say, give me the thing with that corresponds to NA, this it's always going to return a missing value on the output. All right. There's a few special cases. If you subset using nothing, it's going to give back everything. All right. You probably see this most commonly for matrices when you say, I want like nothing, comma 3, and it will give you everything in the third column type of thing. Okay. And then if you use 0 or null, you get a 0 length vector. Okay. So in this case, subsetting using the integer 0 returns back a numeric vector of 0 length. All right. If you have set names, okay, so here I took x and I set names here, which are going to be the letters A, B, C, and D, then y looks like this. Okay, now we have a named vector. All right. So if you have a named vector, then you can subset using the names. You can say I want the elements named D, C, and A, and indeed it gives us back those elements. No surprise there. Okay. Like integer indices, you can repeat them, and so you can say give me A 3 times, and it will do that. Okay. When you use a single square bracket, though, it has to the names have to match exactly. Okay. So here I've got the first element is named ABC, and the second element is named DEF. And so if I say give me A and D, it says those values don't exist, right? So if you try to subset with basically referring to something that doesn't exist in the vector, it gives you back a missing value. Okay, so here's something useful. You can create a lookup table, right? So here we have some vector, mf, okay, uffmm, okay, so maybe a vector of genders, right? And maybe we want to replace every instance of m with male and every instance of f with female and every instance of u with a missing value, okay? And so here I just create a vector called lookup. This lookup only has 3 elements in it, okay? It's got an m, male, female, and na with the names m, f, and u. Okay, so I give the names here. And so now if I kind of perform a quote subsetting operation, so it's not exactly subsetting, but we're quote subsetting this length 3 vector with x, where we're basically repeating the indices, okay? Now I've created, basically I've turned every m into male and every f into female, okay? So so we can take these things and do that, right? And then if you want to clean up, you can then unname it, and you get everything back like this. Okay, so so this is handy. This is very handy if you have something that, every instance of this thing needs to become this thing. You can do that, right? So it doesn't feel like subsetting, but this is still a subsetting operation. You don't have to create some kind of if-else statement, like if it's m, then replace it with this, and if it's f, then replace it with this or something. You can just use a subsetting operation. Okay. Let's talk about lists, all right? Subsetting a list works very similarly to subsetting an atomic vector, okay? But there's a very important distinction between how using a single square bracket and using a double square bracket operates for subsetting, okay? So the double square bracket will pull out the components of the list, whereas the single square bracket will subset the list and always return a list, okay? The analogy here, well, okay, let me just read all of this stuff, okay? Oops. The subsetting operators, the double square bracket and $ are similar to using this, okay, except it only returns a single object and allows you to pull the pieces out of the list, okay? The $ is very much like the double square bracket, except you can use it with like named components in the list, all right, which we're very familiar with, I think, all right? So the analogy here is if you've got some list X, you can think of it as a train carrying objects, okay? X double square bracket 5 is the object that's inside train car 5, okay? Whereas X single bracket 4 through 6 is the actual train. It's the, it's like taking out, train cars 4, 5, and 6, and so you still have a train, okay? And if you do X single square bracket 5, it's the train car 5, and then if you want to get what's inside, you need to use the double square bracket there, okay? I've got a bunch of examples to kind of differentiate the differences here, okay? All right, so here, I'm creating a list. There's 2 elements, right? So you can think of train car X has the vector 1 through 4. Train car Y has the vector 9 through 6, okay? If I do double square bracket 1, then I get the contents 1 through 4. And if I do double square bracket with Y, then I get that vector, that contents 9 through 6, okay? So, so if you want to use double square brackets, you can only provide it one element, okay? Because you're getting the contents inside a train car, so you can only specify one car. You cannot specify, I want the contents inside multiple cars, because they might be of different types. It's not going to be necessarily clear how you should combine the elements that are actually inside there, right? If you want to refer to multiple things, like I want train car Y and train car X, you can do that, okay? You can specify multiple elements with a single bracket, and it indeed gives you back the cars themselves, okay? The list elements, the list themselves. So the result of this is a list with element Y and element X. Inside Y is the vector, and inside X is this vector, okay? But if you do double square brackets and you give it Y and X, all right, it's going to error out, okay? What it tells us is it says subscript out of bounds, and when you do something like this, what it's actually doing is doing recursive subsetting, okay, which is the equivalent of saying I want double square bracket Y and then give me double square bracket X, okay? So it's saying look inside train car Y, and within train car Y find the element called X. But there's no element called X, and so it gives us this subscript out of bounds error here, okay? So if you're going to use double square brackets, you can only really provide it just one element inside the double square bracket, okay? Or you're going to set in motion recursive subsetting, which is useful if you know what you're doing, but it takes a little while to get used to it, and I would say just avoid it until you're really comfortable with the idea. All right, so here's some more examples here. I create a list D, okay? So list D is a list of 3, okay? If I ask for the structure of D, it's a list of 3. I've got element A, element B, element C. A is integer, or I'm sorry, A is numeric, okay, double, 1, 2, 3. B is logical, and C is character, right? So if I do a single square bracket, this gives me back the list, right? So D, give me the first element in D. So we've got a train of 3 cars. D single square bracket 1 gives me the first train car, okay? So it basically says it's a list, and inside that list is the vector 1, 2, 3, all right? And if I say what is the type of data it is, it's going to say it's a list. There's stuff inside the list, but inherently it's a list, right? On the other hand, I've got D double square bracket 1, and that gives me the contents, what's inside this train car, what's inside the list, and that is a type double vector, okay? All right, so here's the single square bracket and double square bracket. You always get back a list when you use single square bracket. That's, if there's one thing to walk away from today's lecture, this is it, right? If you subset using a single square bracket on a list, you're always going to get back a list. All right. So here's another list, okay? Again, three elements, integer, character, integer. Okay. This time it's not named at all, right? So there's no names here. So L1, single square bracket 1, gives me back a list, right? And the way we can tell that this is a list and this is not, okay, especially if there's no names, is that this gives us the double square bracket notation, right? So we got double square bracket 1 and then single square bracket 1, okay? And so this is always, you know, R always prints this out at the front of the lines to kind of give you some reference point as to where you are, right? So the single square bracket 1 says, you know, the first element in the vector, and this is basically saying the first element in the list, double square bracket 1, okay? Whereas when you use the double square bracket, the contents, it returns back the contents, so it's not a list, and you just get the single square bracket, and it's the vector, right? So when you're reading output, as you become more and more familiar with R, your eyes, like I don't know right now if your eyes just kind of ignore the single square brackets and stuff that appear at the front of every single line, okay? If that's the case, you know, try to train your brain out of that because it does give important information. Anytime you see a double square bracket, your brain should automatically say, I've got a list going on here, okay? And how you handle that is going to be different from a vector. All right, so what happens here? If I do L1, single square bracket 1, single square bracket 2, what does it give back? It gives me back, what is this? It's not the null object, it's a list with the null object, okay? So it's a list, and inside the list is the null object. It gives you back kind of this empty train car here, right? Whereas if I do double square bracket 1, okay, oops, it's going to pull this out, and then we can say, give me back the second element, and it does this, right? So it gives me back the element 2, right? This thing, if I did double square bracket 1, 2, this is the recursive subsetting, and this is equivalent to doing L1 double square bracket 1 and then double square bracket 2. And you can use a double square bracket for an atomic vector, and it will give you back the second element in the atomic vector, okay? So these two lines are almost equivalent. This one just uses a single square bracket, but that's what we got going on, all right? All right, here I'm going to put a list inside a list, okay? If I ask what is the length of L2, what is the length of L2? It's a length of 3, right? And then the first element is itself a list of 3, okay? But so what we've got going on is basically you can think of this as a train where there's 3 cars, 1, 2, 3, and inside the first car is another train of 3 cars, okay? So if I say, how long is this train? The outside train has 3 cars, and then inside the first train car is like another like mini train. It's like, I don't know, putting a train inside of a train, and that thing has 3 cars in it as well, okay? All right, and you can keep going, right? If you wanted to, right? I don't know, do people still talk about like inception memes or whatever? But it's kind of like that, all right? So we're putting a list inside a list, or you can visually, I don't know. For me, it's helpful to think of these as trains, all right? And so we've got basically a train inside one of the train cars, okay? All right, so this is what we've got going on. All right, so how would I reference the letter B here? How would I get that, this lowercase b? I would do L2, and then I would say, look where?
Inside of L1.
Okay, but how do I, but it's not even named L1 here, okay? So I'd say L2, and then what do I use?
Bracket 1.
Bracket 1 or double square bracket 1? Okay, so because I want to look at what's actually inside the car, not the car itself, if I did single square bracket 1, it'll just give me the car that has the train inside, okay? Because I want to actually look inside the inner train, I've got to use a double square bracket, right? So I'm going to say double square bracket 1, and that now gives me the little train inside, okay? And then I want element B, so how do I get that? So now I'm looking at the little train inside, which has 3 cars. So how am I supposed to get to the B? So I've got L2, double square bracket 1, and then what do I do?
Double square bracket 2.
Double square bracket 2 to get to the middle car inside this mini train. And then once I'm there, then I do single or double square bracket 2. Okay, I want this, so it's going to be L2, double square bracket 1, double square bracket 2, and then single square bracket 2. Okay, and that will give us the letter B. Okay, well, that's pretty much what we're going to do, right? So here, if I do L2 single square bracket 1, it gives me back the entire train, right? And it says, so single square bracket 1 is this, this notation's a little bit hard to read, but when you get used to it, you get used to it, right? So this will say, all right, it is a list of 1, and inside this list is this entire list, okay? And this list consists of 3 train cars, train car 1, train car 2, train car 3. The contents of train car 1 is this atomic vector. The contents of train car 2 is this vector, and the contents of train car 3 is this vector. So it's, so we get that. So this single square bracket gives me back the car with the train inside, okay? And that's what we have. Indeed, it says it's a list of 1 with a list of 3. Okay, double square bracket 1 just gives me the train that's inside, okay? So it says, look inside the first car. What do you see? Oh, I see another train. And so it gives me just the list, this thing here, all right? And indeed, when we look at the structure, it says so. It says L2 double square bracket 1 is a list of 3, okay? All right, and so when you do this, if you use a single square bracket, this is looking at the first car inside, and that's a list. And if you try to do 1, 2, it's going to say, you know, you've subset it to the first car, and you're asking for the second thing. There's nothing there, right? So it gives you an empty thing, right? Whereas if you do double square bracket 1, double square bracket 1, this gives you the vector. And then if you say double square bracket 1, double square bracket 1, 2, this will give you the second element in there, okay? So again, this is the entire list. The first double square bracket gives us this list. The second square bracket, double square bracket, gives us this thing. And then the final 2 tells us I want the second element. Okay, that's what we have here. Okay, you can use double square brackets on atomic vectors. That's not a problem, okay? And they behave similar to using single square brackets, all right? If you're giving it just 1 element, okay? The difference is that a single square bracket will preserve things like names in an atomic vector, whereas double square brackets will drop names, okay? And then how it handles out of bounds things is also different, okay? So here I've got just an integer vector, 1, 2, 3, and the single square bracket, and if I say, give me the fifth element, all right, so I've got 3 elements, and I say, give me the fifth element, this just returns back a missing value, okay? Whereas if you say double square bracket 5, then you get this, error, subscript out of bounds, right? If you give it a null or a 0 on an integer vector, on an atomic vector, it gives you back a 0 length vector. Okay. If you give it null or 0 with double square brackets here, it's going to give an error. Okay. I didn't do this, but let's see. Okay, let's do another thing here. All right, so and I guess this is another difference here. All right, so here's x, and I can say, give me 2 through 4 here. What will happen if I do this? Atomic vector, I'm using double square brackets, 2, 4. Will this work? Will this throw an error? What do you guys think?
Throw an error.
Indeed, it tells us that we're trying to select more than one element here. Okay, with in this thing. Okay, for an atomic vector. Yeah.
Can you use colon notation for double brackets, like select multiple?
If for a list you can, but then you're doing recursive subsetting is what you're doing. Okay, so if you use colon notation for a list, so if you got like a list inside a list inside a list, then you can do it. So so I'll call this L1, and it'll be a list. Oh, gosh, so I'll do A1, B. Let's see. I got to make it a list inside a list inside of a list. A list, capital A will be, I don't know, 3, and B will be 1, 2. Instead of 1, 2, 3. Okay, I think this will work. List inside a list. Okay. All right, so let's look at the structure of L1. Okay, so I've got a list of 2 on the outside. Inside there, I've got a list of 2 things. And then so I think I can do L1. I can do double square bracket 1. And then I can do double square bracket 1 colon 2. And this will give me the second thing. And then if I do 1 through 3, it will give me the third thing inside of this second thing. Okay, so this is... Okay, but this is like, again, this is equivalent to doing this, right? So these 2 things are equivalent, but then this means you just need to have this very specific structure where you happen to want exactly the third element in the second list inside the first list, right? And if you're going to use some kind of colon notation like that, right? Because colon notation generally creates a sequence of integers. And so if you don't happen to want the 9th thing that happens to be in the 8th thing, inside the 7th thing, inside the 6th thing, then colon notation is pretty much useless, okay? I mean, I guess, so if you use double square bracket notation with a vector, it's generally going to be in a situation where you say, I want, like, inside the 4th thing, I want the 2nd thing, and then the 3rd thing, or something like that, right? And this is going to error out because it doesn't exist, right? But that's where it would work, okay? But I imagine in 99.99% of situations, using a colon inside a double square bracket is not going to be useful. Okay, so we saw this happen a few times. So here is our list L1, okay? And if you use single versus double square brackets for out of bounds or null indices, I'm going to just show you kind of the effects that this has, right? So L1 has 4 elements in it. And so if you say, give me, 3 elements in it, 1, 2, and 3, double square bracket 1, 2, and 3 inside this list. If you say, give me single square bracket 4, it just gives you back a train car with null inside, okay? Whereas if you say double square bracket 4, this tells you subscript out of bounds, right? This is super, super, super common, I would say, as far as when you do a for loop and you've created something, you often run into this subscript out of bounds, okay? And what that generally means is you're specifying something in a list or maybe a matrix where that element doesn't exist, right? You've probably, in your mind, the index that you're operating, like if you say like for I and 1 through 20 or something like that, that I is referencing to some index that is different from what you're expecting. Okay, list with null, single square bracket null, returns back basically an empty list, a list basically a quote train that has no cars, okay? And then double square bracket with null will give you an error, okay? I know this is a lot of rules to learn and remember, but these are the differences between code that works and doesn't work. All right, is that all right? All of this single versus double business with lists. All right, we can talk about subsetting matrices and arrays. All right, probably the most common method is to subset using multiple vectors. So if you've got a matrix, two-dimensional matrix, you'll probably give it like which rows you want and which columns you want and things like that, okay? Matrices are implemented as atomic vectors with dimensions, so you can also give it just a single vector. And you can also subset it using a matrix of basically coordinates, okay? All right, so here I've got a matrix, 3 by 3 matrix. I've named the columns A, B, and C, all right? And you can just say, I want the first 2 rows, 1, 2, right? Or you can give it a logical vector, all right? True, false, true. This is not recommended to use T, F, and T. Why not? Versus the full words true and false. No? Okay, so all caps true is a reserved word in R. It will always take on the logical value true, right? When you start up R, capital T is basically a variable name that currently is equal to true. But if you wanted to, there's no rule against using the letter T to refer to something else, okay? So you can say capital T is now equal to 5, or capital T is equal to 0, okay? And if capital T equals 0, then we're in trouble, okay? Because now what we think means true will actually get coerced into false and stuff like that. Similar with F, right? If capital F is equal to 1, it's going to get coerced into true. Or if capital F gets coerced is equal to anything other than 0, it's going to get coerced into true. Whereas capital false, all caps false is always going to be the value false. But anyway, here, first row, not the second, third row, give me that, and then give me columns B and A, so on and so forth, okay? I think you guys are familiar with this, right? This says give me no rows, and don't give me the second column. You can do stuff like this, right? So we're giving it 2 vectors, 1 for the rows and 1 for the columns, right? And you need to, the important thing is you include a comma here, right? And so here, by including a comma, it says this vector applies to the rows, and this vector that doesn't exist, this space here, applies to the columns. And we said giving nothing will return everything. Okay. One thing to note is that when you subset a matrix, okay, and the result is a vector, it's going to simplify to a vector. I'm sorry, so not the if you subset a matrix so it's only one dimensional, like just one column or one row, it's going to simplify it down to a vector. So so A is a matrix, and if you say is it a vector, it's going to say false, right? Over here, if I take A and I say give me back just the first row, it gives you back the first row 1, 4, 7. And this is just a vector. It's not a matrix. It's a vector with names. Okay? And if you ask, is it a vector? It's going to say true. Right? So there's no dimension here. We know it's not a matrix because we don't see anything like you would see a square bracket, 1 comma, or something if it's a matrix, or at least row names or something like that. And that's not the case. So here I've got the first 25 letters of the alphabet, and I arranged them in a 5 by 5 matrix, okay? And because this is just an atomic vector with dimensions, I could just say, give me the 8th and the 9th values, right? So it's going to count through down the columns, right? So E is the 5th, and then F is going to be the 6th, and so the 8th and 9th will be H and I. Okay, so we can do that. Is that all right? Okay. You can also subset a matrix using a matrix. You can give it coordinates, basically, right? So you can say, give me the element. So if I wanted to spell out UCLA, okay, I could say, give me row 1, column 5. Give me row 3, column 1. Give me row 2, column 3, and row 1, column 1. Okay, and that's what I'm specifying here. Okay, we're basically giving it coordinates for the values that I want in a matrix. So here I've got a 4 by 2 matrix. Okay, each row corresponds to an element that I want, and then the 2 columns corresponds to basically the row and column coordinates. Right. So if I want the letter U, I have to say it's in the first row, 5th column. Okay, and that's what I'm doing here. Does that kind of make sense? All right, and so this can be generalized to higher dimensions. So here I've got a 3-dimensional array, all right, 1 through 12, 2 rows, 3 columns, and 2 sheets or 2 layers. And so here it will say I want first row, 2nd column, 1st layer, right? So first row, 2nd column, 1st layer, okay? So that's going to be the 3. 2nd row, 3rd column, 2nd layer. So if I go to the 2nd layer, 2nd row, 3rd column, that's going to be the 12 here, okay? So because the array exists in 3 dimensions, the coordinates that I specify here have to be in 3 dimensions as well. Okay, and so that's what we've got going on. So you can subset a matrix or an array using another matrix, 1 column for every kind of dimension and 1 row for each element that you want. I would say this is probably the least common way of subsetting a matrix, but this method does exist. You know, if you need to use something that way, right? So I don't know, if you have some kind of table of something where you want to kind of like look up like what was the value for I don't know, May in this year or something, you can do it that way. Okay. All right. Let's talk about subsetting data frames. This is going to be our last section here. Okay. So data frames are lists. Okay. But they have 2 dimensions, and so you can subset them the way you would subset a list, or you could subset them the way you subset a matrix, okay? So here, here's a data frame, 4 rows, 3 columns, okay? And here I'm going to subset it like a matrix, right? So here I give it a logical statement. When y is mod 2, so when y is an even number, okay, give me back those rows. And so it's going to give me back the first row and the 3rd row, which is where y is an even number. Okay, so this is subsetting it using a logical vector, subsetting like a list, like a matrix. Okay, Whereas, and we know it's subset like a matrix because there's a comma here, right? I don't have a comma. I give it just a single vector. Now it's subsetting like a list, okay? So if you think of the way the data frame, it's stored as kind of a named list, all right? So it's just saying, give me back the elements in the list named X and Z, and that's what we've got going on here, okay? You can give it the comma, and now it's subsetting like a matrix. Give me all the rows where the columns are named X and Z, okay? Or here, subsetting like a matrix, I can say give me the rows 1 and 3, and I put in the comma, okay? If I forget the comma, then it gives me back columns 1 and 3, all right? And so this is a common mistake that people make when subsetting a data frame, is if you just forget the comma, and this is like hard to notice sometimes when you're trying to debug your code, you have to look at the output and say, well, what would cause me to get this thing? If you forget the comma, you're in trouble, right? So including the comma will choose the rows. When you forget it, it's going to choose the columns. Okay. One key difference is that when you use the single square bracket and a name, it's going to give back a data frame. And if you use the comma and the name, it's going to simplify it down to a vector. Okay. When you use $ notation, $ will always simplify down to a vector. Okay, if it's a vector as well. All right. And then the double square bracket, which is pretty much equivalent to $ notation, always, again, like the list, pulls out the elements inside and will simplify to a vector. Okay. We've covered some of this stuff already, but I'm going to just kind of fly through this a little bit. Simplifying versus preserving. Okay. So we already saw this for atomic vectors. Single square bracket will preserve things. Double square bracket will simplify things in that it drops names. Okay. With a list, a single square bracket applied to a list preserves it. It always returns a list. A double square bracket applied to a list will simplify it by pulling the contents out, and you'll get kind of the contents if it happens to be a vector or something. Okay. Factors are kind of a special case. All right. If you use a single square bracket on a factor, it's going to preserve it. If you include this optional argument, drop equals true inside the square brackets, it's going to drop any levels that aren't used. So here, the original factor had levels A, B, and it's going to keep those, even though there's no B's inside the factor. Here, because no B's appear in the results, those get dropped. All right, and this, it feels weird throwing in an optional argument into the single square bracket, but this is what we have. So this is, I would say this is a common use of, I would say this is the most often when I use the word drop here for in our R code, is that if you want to subset a matrix but preserve the matrix structure so that you can do like multiplications and stuff like that, you can include drop equals false. So here I'm saying give me back row 1, all the columns, and preserve the matrix structure. So this is going to be a 1x2 matrix. Whereas if I say give me back just row 1, okay, and all the columns, R will say, oh, that looks like a 1x2 matrix. I'm going to simplify that just to a length 2 vector. All right, so R's default behavior is to simplify down to a vector. But if you want to preserve the matrix structure so you can use it in matrix operations, you can use drop equals false. Okay. Data frames, we saw this single square bracket preserves the nature of the data frame. Double square bracket will extract the elements, reserve as a vector. Okay. This is okay. What did I do wrong here? So here is the empty cars data set, motor trends cars, and what I'm going to do is I'm going to say I want cylinders less than or equal to 5. Okay, so here's the column. We got 6-cylinder, 4-cylinder, 8-cylinder vehicles. What am I doing wrong here? Why am I getting an error?
Yeah, comma.
I left out the comma, right? So when I left out the comma, this is basically becoming a logical vector, and the logical vector is going to get applied to all the columns, right? So I don't know how many elements there are, but like maybe there's 30 elements, and I've got this length 30 logical vector, and it's going to start looking for like the 18th and the 20th column, which doesn't exist. I think there's only 12 columns. Okay, so if I include the comma, then it works. I've got only these 4-cylinder engines. Okay, what happened here? So I have the comma, and I said empty car cylinder is equal to 4 or 6. But when you look at it, okay, I'm getting some with 8. So why am I getting cylinders 8? Even though I said cylinders equal to 4 or 6. It's a 6. Okay, so what's happening is that when R looks at this, it processes this part as a logical vector, okay? And then it processes this as a logical vector, okay? The 6 gets coerced into a true, okay? The 6 gets coerced into a true, so it's gonna say empty cars is 4, the cylinders is 4, or true, which is gonna be true for everything, right? So if you say something or true, so it's gonna be true for everything, so that's why it's returning everything. If you want cylinders to be 4 or cylinders to be 6, you gotta specify 2 separate logical things and then use the OR operator, and now we don't get the overlap there, okay? Same thing here, if you leave out the comma, so don't forget the comma. That's kind of the moral of the story of these examples here. All right, have a good weekend. We'll see you guys on Monday. Oh, you guys got the message that the midterm date is different, right? It's gonna be week 6, Wednesday. I try to send it out in multiple ways, so make sure you mark your calendar accordingly.